As we look in detail at these parts, we'll start with the air intake here and the air filter. One thing to think about with air intake systems is there's a couple of things that have to be designed into that system. In an ideal world, what we're looking for is the minimal restriction possible. So in theory, we could simply remove the air intake here and just pull air directly into the throttle body and into the engine. That is almost what happens with race vehicles, but in real life, on real roads with production vehicles, there's other things that we need to consider. So one of those things is that we want a source of cold air. So although we want minimal restriction, we also want cold air. If we pull air from here, it's likely to be warmer because it's so close to the engine. So we route over to somewhere that we can get some cold air. The other thing to consider is noise. So on a race car, that's not a consideration at all. They make as much noise as they feel like. But on the road, manufacturers need to comply with regulations. And there's strong regulations around the amount of noise that an engine can generate. So the air intake system has to be designed to reduce noise from the engine. On this vehicle, our source of air, our air intake, which is this, we have an opening here that sucks in fresh air. This is located just behind the bumper, kind of just off from the radiator, inside the engine compartment. That's a good place, we've got good airflow there, it's reasonably cold. Another place that's quite common to pull air is from the base of the windshield, where the windshield meets the hood. There's an area there which is also a good source of fresh air. It has some pressure differentials going on there as the vehicle moves through the airflow. Now, having discussed the location, there are other places that we could put this intake. Cars use all different locations and people reroute the location of their intake depending on what they want to achieve. This one is, as I say, inside the engine compartment, just quite high up. And the reason it's high up, that cuts down on water ingress. So the lower you put an air intake, the more dirt and grime you're going to pick up from the road, but also the bigger risk of water making its way in there and generally causing problems with the system or soaking the filter, something along those lines. Now, if we look at this air intake housing, what we've got down here is a bell mouth. Can you see that this pipe just slightly flares outwards as it opens up? Any sort of intake for air or gas will have what's called a bell mouth, which is where it flanges outwards and almost mushrooms slightly. That is much more effective at pulling in air than simply ending in a sharp pipe like this. So you'll see that somewhere. What we have on here is a curve, which is for noise reduction, so that prevents noise from traveling out in a straight line. The next step is we need to filter that air. So all the air that goes into the engine needs to be cleaned, because in the air we've got things like dirt, dust, insects, moisture, and all of those nasty contaminants we really want to take out of the air. Any sort of particles that get into the cylinder are going to do some serious damage and they're going to shorten the engine life. So air from here not only goes into the cylinders, but it also makes its way into other parts of the engine through a system that ventilates the crankcase called the PCV system that we're going to talk about shortly. But what we need to know is that all air that goes into the engine, either via the intake manifold into the cylinders or through the PCV system, needs to be cleaned. And so we have our air filter box here. Let's pop off the intake and have a look at our air box or air cleaner and see what we've got inside. So your standard filter is paper based these days. What we've got here is a sheet of paper which has been folded up. So we've got all these different pleats of paper. Essentially it's compressed and that creates a bigger surface area. So what we want is the biggest possible surface area for the air to flow through that's going to cut down on restriction. Because with air filters, we've got two almost incompatible aims. We want as little restriction on the airflow as possible, but we also want a good, strong filtering performance and effective removal of particles and dust and so on from the air. And so to effectively filter the air, there should be lots and lots of tiny little holes in here. Those holes as small as possible, but the smaller the holes, the greater the airflow is restricted. So what happens with a filter as it wears? I'm sure you know that filters need to be replaced at service intervals. Here we have an old filter which is the same, and you can see, if we get inside there, you can see all this grime and dirt which has become clogged up in the pores of this filter paper. So over time, inevitably, this stuff just ends up getting bunged up, and that reduces the airflow through the system. And the reduced airflow reduces the performance of the engine. So you replace these. They're relatively cheap, and it's well worth replacing them, because you replace a very old, worn one like this. I mean, look at this as we do this. Look at the amount of gunk falling out of here. That stuff is all reducing airflow into the engine. Absolutely filthy. So if we were to replace something that's as dirty as this one with a nice, fresh, clean one, that's probably going to improve engine performance maybe by 5%, something like that. The statistics bear out that these filters really make a difference on the performance of the engine. Now, that said, this is an OEM filter. What we can see here when we look at the quality of these filters is this one has a much higher number of pleats than this one. Now, does that tell us very much? Not really, but it does tell us that there's a bigger surface area on here. They've used more filter paper. Now, it may be that this one has a higher quality filter paper. It's hard to tell, but there are differences in quality between these filters. There are kind of premium filters out there which claim to boost performance of the engine or increase horsepower, something like that. I'm a little suspicious or skeptical of these claims, because my thinking on it is that if, for the sake, these things, let's say these cost $1 or $2 to make, they're very, very cheap to manufacture. And even the premium ones, I can't believe they cost more than a couple of dollars to produce. So for a vehicle manufacturer, if they could improve the performance of a vehicle in a noticeable way for the sake of a $2 air filter, then I have to think that they would do that. You know, these guys are the experts. I find it hard to believe that later down the line, somebody else can produce a filter for $2 which improves the performance of a modern engine. That said, there is a benefit to some of these premium filters because they can be reused, or they maybe have a longer life. And so there's some eco-credentials to be had there in terms of not wasting as much materials in throwing one of these out every year or two. So, in addition to our stock standard paper-based filters, we also might find we've got foam filters that use a foam filtering element. There's also ones that use a metal wire mesh potentially, and cotton is somewhat of it's seeing a resurgence in use. So cotton used to be used on very old vehicles. Nowadays, there are some manufacturers that are putting cotton filters into vehicles. Often that cotton is impregnated with some oil that helps it to grip and kind of hold on to contaminant particles. You've got aftermarket filters as well. So what we've got here, this is a cone filter. So we've got here, you know, the standard rectangular air filter. This is what's called a cone filter, and this will be fitted on a short ram air intake or a cold air intake. It doesn't have the noise reduction that comes with a airbox. So it's not surrounded by an airbox. You're going to get an increased noise from this from the vehicle. So on a production vehicle, you're unlikely to see this because that production vehicle has to pass the regulations. Once it's outside, on the market, on the road, people replace the filters with these because they'll still pass, or, you know, don't hold me to that, but they're probably still going to pass your annual inspection or whatever takes place in your market. In the UK, we have the MOT. So this would still pass that as long as the emissions, and it doesn't affect the actual emissions outputs of the engine. So a cone filter like this, and these are often washable or reusable. You can blow them out with compressed air, or, you know, wash them out, or even buy specific cleaners for them. Other types of air filter that you might find in a very high dust environment, if you're driving around in a big old JCB, something like this, or a tipper truck, something that works on a building site or a construction site, you find what's called an oil bath filter, which is where the air is filtered through a bath of oil that removes all the dust particles. Because if you're operating in a very, very dusty environment, even the desert, if you're on an off-road vehicle in the desert, dust will block these up. And of course, you can take them off, knock out the dust. If it's large particles like that, you can knock it out, blow it off with compressed air and use it again. But the dustier the environment, the faster that these filters will get blocked up. So those vehicles would tend to use an oil bath filter. Now, once you've got your blocked filter, as we said, this is going to lower the fuel economy, it's going to reduce the performance of the vehicle. So for the sake of what, $10, $15, whatever one of these costs, you're going to waste that amount of fuel in, I don't know, a few weeks probably. So it's obviously well worth replacing filters. One other thing, sometimes nowadays you'll find a second filter in the air filter system. So you'll have this filter, which is replaceable, service item, and there'll also be a charcoal filter that maybe fits behind this or somewhere else in the vehicle. Now that charcoal filter is there to reduce the emissions of the vehicle. Essentially, when the engine's off, you've got fuel vapors and all sorts of nasties that could make their way back out of the intake system from the engine, coming backwards along. That charcoal filter is there to prevent those fuel emissions and those nasty chemicals, hydrocarbons, from going back out into the air outside the vehicle. Those charcoal filters tend not to be replaceable, so you'll only be replacing this. The service item, the charcoal filter, stays where it is. We talked about the noise reduction function of the intake system. Let's just quickly go over that again. So we've got noise reduction that takes place from the bends and the shape of the intake. We've also got the airbox itself, which cuts down on noise. And along the pipe here, we have a chamber, a resonating chamber here, also called a Helmholtz chamber. What that does is it functions in two ways. It smooths the airflow, creates a little bit of a improvement in the air intake system, pumps a bit more air in via the harmonics in the air system that we'll talk about shortly. So it actually has a performance increase on this vehicle, but it also cuts down on the amount of noise. So just to briefly explain that, as the engine's running, we've got not just a one-way sucking of air. It doesn't just smoothly get sucked into the engine like this. What we've actually got is a motion which is creating vibration in the air as well. So it's sucking some, then pumping some back, sucking some, pumping some back. It's not a completely smooth, seamless process. There is vibration, oscillation, harmonics, whatever you want to call them, hammering inside the air here. And this chamber, in some complicated fluid dynamics way, assists with that. This chamber here is sized based on the size of the cylinders, each cylinder in this engine. The volume of this chamber is dictated by that. Super complicated stuff, but just know that this functions to improve a bit of performance at low revs in this engine, but also to cut down on the amount of noise coming out. On the air filter box here, or somewhere on a system for any vehicle, but in our case on the air filter box, we have the intake air temperature sensor, IAT sensor. It's an important part of any fuel injection system. This allows the ECU to know what temperature the air being sucked into the system is, because the colder the air, the greater the density, the more oxygen that there is in that volume of air, the more fuel needs to be pumped in. So this sensor goes into the calculations that the ECU makes in terms of how much fuel to put into that engine and how to control the timing. This system needs to be airtight. So once the air has passed the mass airflow meter here, the ECU has measured the amount of air in the system, and any leaks in this system beyond this point here will cause the ECU's understanding of the airflow to be wrong, because we've got air coming in here which not only is not being measured by the system, but it's also not being filtered by the air filter. So from here on, in fact from past the air filter onwards, the system should be airtight. And it's easy to think, well, it doesn't matter if there's air leaking into the system here because ultimately it's all air. Well, there's the issue of the air being dirty and contaminated, but there's also this issue that that volume of air is not measured by the ECU.